basically a review thing that I did with, I made up with some factory problems, some things to remind ourselves on how to do, stuff like that. I try not to make it too fancy or crazy because we've kind of done all the hard stuff. So in this case, I have, whenever I see 4 terms, I'm automatically going to ask myself if I can group them. If I can do that, it just makes my life easier. So if I look at this and this, is there GCFs? If I take out the x to the 4th, I'm left with 2x plus 1. If I take out a negative 16, I'm left with a 2x plus 1. That's the fastest way to go about this problem. So now you have x to the 4th minus 16, a 2x plus 1, which gives you x squared minus 4, x squared plus 4, 2x plus 1, which gives you zeros at plus or minus 2, plus or minus 2i, and negative 1/2. Now, what happens here is that when you have an imaginary, that just means the 0 doesn't occur on the x-axis. The 0 is going to occur someplace else. So what we do is we plot our our tails like we would normally. So we have a negative 2, negative 1/2, and a positive 2. This was a 5th degree polynomial, so it's got to do a down up. So what happens here is usually your imaginary, because it's going up like this, it's got to change. It might come back up and do this again, somewhere up in here, or it might do another dip through down here. You really won't know unless you use a graphing calculator. So when we get to it on the test, if I possibly have you guys plot and graph, because I don't know, I might, I wouldn't make you have to do it with an imaginary, okay? Does that make sense? I've made sure, I might have made sure, or maybe will be making sure. I'm trying to be as vague as possible, can you tell?
Yeah.
I'm good at that. So, if you do have to, well, okay. When you do graph zeros and plot with the tails, I will make sure your zeros are real, okay? That one just slipped by me when I was trying to pick some problems real quick. All right, what else we got?
I actually synthetically divide that one, I got the same.
Yep, you can. And that's the idea. Synthetic division always will work. It's just that if you see a 4-term, anytime you see 4 terms in a polynomial, see if you can group it real quick via GCFs, because it's just faster. That's all.
Wait, I have a question, because
Yes.
I did the synthetic division and I got the zeros for 4 and negative 4, but then like that's what you got up there. But how do you know if you're supposed to do x squared?
When you got to the 4 and negative 4, when you rewrote what your polynomial was, you should have noticed that you could have factored it further.
Okay.
Okay, that's the whole idea when you're doing synthetic, because you have to remember that you drop degrees. You might have forgot to drop degree.
Yeah.
That's all. What else we got? What do you got, Trav? Come on, Trav. What do you got? Come on, down.
57. I mean, no, 56. Sorry. 56 on the other. On the other.
You're pressing buttons on the calculators, guys. That's all you're doing. That is all you do. That's it.
Then you write down the year, right?
Probably. All you have to do is read your calculator. It is, I don't know, we have to, I mean, seriously, ladies and gentlemen, we really, 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 really have to get over this aversion of reading a problem. You have to understand that. You're going to see these over and over again. We have to be able to understand that it's just using a calculator. You have this really awful looking polynomial that tells you that from 83 to 95, the amount of private donations in millions of dollars where allocated education is modeled by this, where T is the number of years since 1983. So what is year 0? Year 0 is 1983, okay? That's the idea that you have to get through your head here. That's where it starts at. So you just go to your calculator and you quite literally put this in the calculator. 1.7, get your calculator out. Yes, I can't know
Mr. Murphy,
what?
were we supposed to write down the years?
I don't know. I haven't read the problem yet. 752x and a 6701. Okay. So now, remember yesterday I showed you guys how to adjust your table set. When I'm doing this type of a word problem where we're looking at years, sometimes it's always nicer to understand that year 0 is where you're starting, because that's what the problem does. So if your table is starting at like -4 or 18, you have to backtrack around a lot of times. So just remember second window and just make sure your table is starting at 0. It just makes it a little bit easier to understand what's going on. So now, all you have to do is look at your table. You don't need to look at the graph or anything like that. So this is in millions of dollars. So at year 0, $6.7 million, or wait, is it 6.7 million? Or is it 667? Okay. All right. Oh, that makes sense then. Okay. So what they're looking at here is year 0 is 83. 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, and so on. Okay? That's all you have to be able to do. Where does it go over 14.3? Right there. It goes over 14.3 at, well, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92. In the year 1992. I believe that was Lollapalooza 1 in 1992. Or was that? Or no, Lollapalooza 1 was 91. 92 was Lollapalooza 2. Guess who was at Lollapalooza number 2? Besides me.
Oh, I was gonna say you.
What bands? No, they played Lollapalooza some other time. What bands? Fine. They're actually touring next summer. One of them. One of them was already here this summer. This is really tough. Ready? Red Hot Chili Peppers. I think you've heard it. Chili Peppers were there. Soundgarden, Pearl Jam, Jesus and Mary Chain, Ministry. I think it was Ice-T was there. I know, I love that. That commercial, it's lemonade. This is a great commercial.
It's lemonade.
It's lemonade. Try some, it's delicious. It's funny. But yes, 1992. You guys really don't care, do you?
I do. I'm trying to remember.
It was the first concert I was allowed to go to with friends.
Oh.
How old were you?
16.
38.
In 1992. All right, so if I was 38 in 1992, that means I'm what? Carry the 7, wait, how long ago was 92? 25 years ago?
What year is it?
16. So then I would be 60, 63? Yeah. I'm in pretty great shape for being 63 years old. I had children very, very late in life. I was hoping that I didn't have to put them through college. Ooh, that's morbid.
That's really sad.
63 years old. I like you better when you sit back there. That's funny. Well, one trap.
59.
Population. From 1890 to 1990, the American Indian, Eskimo, and the Aleut population can be modeled by the function blah, 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 blah. Where T is the number of years since 1890, what year the population reached 722,000. So again, we go to our handy dandy trusty calculator, and which button is that? Too many tabs.
75 years ago.
470 years ago, our founding fathers
It's not
brought
70,
forth.
it's 70.
Hey, there's a lot of silly things you guys will remember when you get older, believe it or not.
Yeah,
It was just like a fortnight ago. Fortnight is 40 years. 4 days?
2 weeks.
2 weeks. All right, so I'm looking at my table here, and this case, starting at year 0, that's 1990. So we know it's, or 1890. Okay. Now, all you have to do is just scroll. It's annoying. Takes a while.
75. X equals 75.
So 75. Just keep pressing buttons until you find it. Good work. You didn't pull a thumb, like, get tendonitis or anything, did you?
Just a little bit.
You did? Did you switch hands?
Yeah. I just switched
Stretch it
around-
out?
Yeah, around 60. I switched thumbs.
Take a breather, got a sip of water.
Yeah.
Good work. Good work.
It's not for like this.
Really, the biggest mistake you guys will make with these types of problems, with the word problem thing here, they're quite literally plug and chug, okay? You might miss a sign. Yes, ma'am. Give a $1. Yeah, in class. Yeah. We did this in class. Oh, the other 55. Sorry. The other 55. This one we can't, we're not going to be able to group because there's too many terms. So we have to use synthetic. Okay, so we start with synthetic division. We have plus minus 1 over 1 and 2. Yay! Try it again just to see if one works. Having a smart board for yourself would be pretty nice, wouldn't it? What's that? That'd be great. All right, so we have terms. We have x minus 1, x plus 1, and then here we have 2x squared plus x plus 1. You can't factor that, can you?
It doesn't have any zeros.
Yeah, so this is another one where you're not going to be able to graph the imaginary. It'll probably, all you're going to be able to graph would be your plus and minus 1, which is doing, so it's tails up, so it's doing this. Somewhere else in there, there's probably a little jog because of that. If you look at the calculator. Yeah, somewhere in there, and that's what happens when you use the graphing calculator. I promise you, Leonard, when I have you do this on the test, it'll be all real zeros. It'll be plotable. Was the squiggly line below it or above it? No, was it above or below when you did that? The squiggly. Probably below, right? Makes sense. Excuse me. All right. So, real fast, it's been a while since we've seen one that had a factor that was a cubic that was 2 terms. Sum of cubes, yeah. Remember we had that pattern of sum and differences of cubes? It was, I don't know, beginning of last week or one of those days where we kind of rolled through it rather quickly. What is always your first rule of factoring? Yeah, so in this case here, we got to figure out what a GCF is going to be, just to see what we can do here. If we do it, excuse me, if I do GCFs, let's see, if I take out, what works? 9, right?
No, you get 14.2.
All right, so it's not 9. 6? No. 4?
Yeah, 4 is 32.
So it's 32, okay, so it's 32x cubed and, no, 4 doesn't work. What's 2? 2 works. You get 64x cubed and a 27.
Yay.
Okay? So now, remember how we did this the other day? The sum of cubes was that a cubed plus b cubed, and it equaled a plus b, a squared minus ab plus b squared. Now with this case, you have to remember what's playing the role of a and what's playing the role of b. Ah, b is not 27. What do you have to cube to make it 27?
3.
3. So when you get to a point like this, remember, 27 is 3 cubed. 64x cubed is 4x, quantity cubed. Now that was the reason why we did some of those problems at the very beginning with our exponent rules. So that way you guys remember that when you're squaring or cubing or something like that, to something within parentheses, you have to be able to go to both parts, okay? That's how that one would set up. So now I know that if I go to factor this fully, since it's not equal to 0, that 2 has to go along for the ride, okay? The 2 has to go along for the ride. So it becomes 2 times the quantity, 4x plus 3, because that's your a and b value. When I square 4x, what do you get? Good. You get 16x squared. Subtract.
7.
Try again. 12x. You added them, not multiplied by mistake. And then square the 3 and you get,
9.
and there you go. Now remember, I don't think I have ever seen a trinomial out of a cubic that's factorable, so you're pretty much done. Okay? That's what that one would look like. I know it's been a while since we've seen that. Just make sure you guys have that. Yeah. Yep. Because it just says factor. If it said find all zeros, then you could say you'd have zeros at bless you, negative 3/4, and then I would use quadratic formula for the other one. Let's see what else was on here that I wanted to double check with you guys. Yeah, that's some pretty good stuff. Bless you. Remember, a lot of these things that we've done, I mean, where it's, finding your zeros, finding all zeros, sketch the general shape. When you talk about the sketching of the general shape, that means I'd like you to try, I don't remember if I put stuff in here that was imaginary. I kind of picked these without looking, so let me see if there's an imaginary one on there. Well, and that's what's crazy about using the computer a lot of times to generate these things. You might get imaginary zeros. If that works. 28 is going to have an imaginary 0 on it. 29 will be okay. And 30 is okay. So when it says sketch, what I want you guys to remember is that means you're going to find your zeros, plot them, and go. Okay? Now, would you guys rather me just post the answer sheet?
Yes.
That way you're not just having it right next to you right away, or do you want me to just pass it around and just take a picture of it? It doesn't matter to me.
Yeah.
It's up to you. Want to just pass it around?
Yeah.
I'll post it too. I don't have worked out solutions. That's too much work. What? Why are you mad at me? I'm nice to you. What? Well, you just never mind. We'll start here. You want to snapshot or screenshot it or whatever? Otherwise, I'll pass this through. I will. Hey guys, I will also post that on the website in next hour. So if you don't have it now, you'll have it in like an hour. Well, take a picture of it then. You know
Yeah,
what I
like
mean.
everyone says like your generation says screenshot as a picture.
Well, I know what, bless you, I meant picture. I know what a screenshot is. I know how to take a
Like
screenshot.
my parents say that too all the time.
There's nothing.
It's not you. Dude, none of our teachers any ever collect a review packets that are written points.
I know, I didn't do all that points.
Well, I also look at it as it's review. It's would behoove you to prepare for it. That's why I give it to you.
I mean, I always assume.
Also, if you're looking for other problems and whatnot in the book, I know that we've pretty much done everything in 6.6, 6.7. We did not look at anything out of the book out of 6.8, so you don't have to worry about that. The 6.9 stuff, the only thing we did in there was writing that polynomial out we did the other day where you had to solve for a, which I'm pretty sure you guys thought was pretty easy because it was the same thing as the quadratic stuff. Yes, sir. No, sir. The other than that, the test. I'm looking at the test being there will be a couple of non-calculator problems and there will be calculator problems. I think what I will do is we'll do the calculator portion first, and then you guys will do non-calculator after that. So you just have to ration your time out. It's written so that you guys should be able to finish it well within half an hour. So you'll have plenty of time to go through all of this stuff. So it's not a horribly scary bad thing.
The other, like the last test was short, like the one before that test was long. So was it like as long as the first one?
It depends on the problem. You're right. The one before that was a little bit long, I think. This one I've written it so that way it should be it should be straightforward. It should not be it really shouldn't be more than a half an hour. Okay? Just to prep through on it. It's solve for zeros, sketch something, synthetic division, there's some shortcut factoring if you have to. Long division, I don't know if there's a long division on this sheet. There was? Okay. Remember how to do long division? Things like that. Remember your tails dance?
The holiday stay.
Yeah.
You're doing number 12.
You're doing it to
I'm dancing.
like 6 pages.
Very good.
I should be on the dance team.
You should be.
I would be awesome.
You really would. You'd be the
Yes.
team.
I would be. I would just be. I would be kicked off so fast it wouldn't even be funny. What does 12 look like?
250 x squared plus
250 x squared
cubed.
It's okay with the
plus what?
2.
What's your GCF?
2.
Murphy, you made it through the.
No, can't. I don't want to do it Tuesday because we have to do it Monday. We got other stuff to do on Tuesday.
What other stuff?
We got to start the next thing.
Are we gonna have homework over winter break? I mean, Thanksgiving break.
Well, it depends on how fast you can get the
Oh
stuff
my
done.
God.
What's the cube root?
I forgot to take out.
Yeah, on Tuesday we will start with rational exponents. Not rational. Yeah. And that's actually we're gonna use the same. Remember how we started polynomials with the exponent rules? But we're gonna do the same thing with the exponent rules, but we're gonna have fractional exponents. So you just have to be careful how you add and subtract, multiply, and divide fractions. That's all. Oh, we're out. The sheet's there. What? Oh. It's like you got all. Like we're happy that we're gonna work with fractional exponents. Like, ooh. You've been working with fractional exponents your whole time. You know why?
No.
What's the square root of 4? 2. What's 4 to the half power? What's the cube root of 125? Oh, Maddie, did I say 5? 25 meant 5. What's 5 to the 1/3? Or 125 to the 1/3? And its root? That's all it is.
But how is it like? Can you multiply?
What's that?
Yeah, how you can just like
Here it is.
multiply it or
It's like this.
a half.
They're not multiplying, it's an exponent.
I call it.
It's a fractional exponent. Fractional exponents are called n roots. That's all it is. It's just an n root.